Okay, so the very whole front page is one of these massive graphing problems. So the problem itself is down below there. What do I do?
Can we factor first?
We're going to factor. Okay, and we're going to factor carefully because if we mess up the factoring, we are in trouble. All right, how does the top factor? Think about it. Minus 3 plus 2. And if I do a quick FOIL, x squared plus 2 minus 3, yep, that looks good. How about the bottom?
Difference is squared, so x plus 2 and x minus 2.
Perfect, we are factored. All right, everybody? So now what?
You can do a fold.
Now we see we are going to cancel. So ultimately, we are graphing this. But because we canceled, we know we will indeed have a hole. That's how you get holes in your picture. And where will the hole be? What x value?
Negative 2.
Negative 2. Look, negative 2. And then, what will my y value be?
You plug in negative 2.
Yeah, I don't know. I have to plug in negative 2 here. So negative 2 minus 3.
Negative 1. 5. Oh my gosh. Just kidding.
Negative 2 minus 3 is negative 5. And negative 2 minus 2 is negative 4. But the negatives cancel, so it's actually positive 5/4. So in my picture, at negative 2, negative 5/4, and remember, or excuse me, positive 5/4. 5/4 is like 1 1/4 or 1.25. So that's how you know where to put it. So negative 2 5/4 right here. All right. So now we got to start filling in the rest of those blanks and putting the rest into my picture. Excuse me. So, what do you know?
Horizontal is 1.
Horizontal asymptote. Look at either the original problem or this problem. Where's the horizontal asymptote? 1. Y equals 1. So it's right underneath your hole. Because your hole is at 1 1/4. That's your horizontal asymptote. Okay? Some of you get, y equal and x equal mixed up. I don't know how else to explain it. If you draw your line and it crosses the y-axis, your horizontal line, and it crosses the y-axis, it's y equals 1. Y equals 1. Okay, what else? Here's my vertical.
2.
X equals 2. Look, crosses the x-axis, x equals 2. That's my vertical, comes from the denominator.
X.
What do I get out of the numerator? Something's 3, right? What is that?
That's the x.
That's the x-intercept is 3. 3 times 0. Comes straight from the numerator.
3 over 2 is y.
And then to get my y-intercept, I'm going to plug in 0. And if I plug in 0, I get negative 3 over negative 2, which is 3/2. So 0 3/2 is my y-intercept. Now, you should have all the blanks filled in now, right? Everything's there? So once you get all the blanks filled in, hopefully you can visualize your picture. You can draw your picture. Okay, remember what it looks like. It's always got these arc shapes, right? Like this, like this. Okay, look here. Can you see an arc right here with these points? So you got one that looks like this. Some of you are doing weird things like shooting it up like this. No, 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 remember, it follows the asymptotes. So it doesn't curve back or up or anything, it follows the asymptotes. All right, what's the other one? It's down here with this point, and it follows its asymptotes. Okay, that's page 1. There's a lot of points there though, so we want to make sure we get that all straight. Okay, everyone? All right, solve the following. So this page has all inequalities on it. So remember, anytime you have an inequality, you're going to be doing a number line. Also, we talked about this yesterday, anytime you have an inequality, what do you want that guy to be? A 0. So the first thing we're going to do is subtract that 6x over, and now we have our 0. Okay, so look at that. Does anything occur to you to do with that?
Pull out the X.
You could pull out the x. In other words, factor it. Factor out an x, GCF, pull out the x. So we have an x outside and then x minus 6 inside. So now I'm ready to go to my number line, and I'm going to put 2 dots on my number line because I have 2 x's. But this guy doesn't have a number attached, so where is his dot going to be? 0. And where is this dot going to be? 6. So I have a dot at 0 and a dot at 6. What about those dots? Shade them in. Sometimes I worry about coloring them in, but that's only when I have a denominator, right? So these are the shaded in dots. All right, now what do I do?
Write a number.
Pick a number. And the number I pick is, what?
7.
7?
7.
7's fine. 7's out here. If I pick 7, I get 7 times 1 is 7 times 1 bigger than 0.
Yes.
Yep. So wherever 7 is, I'm going to shade it. And then I won't shade this, and I will shade this. And then I write my answer in interval notation. I hope you remember to do that on your quiz. So negative infinity to 0 this time, and I'm going to put a bracket at 0. I'm going to put a bracket at 6. Does anybody have a question about that?
When is it that you can't do the shortcut and then you want
Okay, we'll hit one of those here in a second.
Okay.
All right. Here is probably the most, other than the first page, which is a lot of work. This one's going to take some work. Okay, what's wrong with it? There's no 0. So we're in the same thing we just did. Only this time, because there are fractions involved, we're going to need to get a common denominator. So right now this is a 1, but it needs to be an x plus 3 so that it matches that. You must keep your denominator because it's going to give you a dot. We're going to go to the number line eventually, right? And the denominator is going to give you a dot, so you have to keep it. What do I have in the numerator? Very careful. X minus 2 minus 6x minus 18. please watch your arithmetic. So what do we end up with here? Negative 5x minus 20. Is that okay? Now, the denominator dot is easy to see. Where is this guy going to be? He's going to be at negative 3. Okay, I know that one. This one's a little harder. So what did I tell you yesterday? If you can eyeball it, great. If you can't eyeball it, what can you do? Equal it to 0 and solve it. So negative 5x minus 20 equals 0. This is, I'm trying to figure out where to put my dot. So negative 5x equals 20. It looks like my dot's going to be at negative 4. So on my number line, I have a dot at negative 4 and a dot at negative 3. The denominator was at negative 3. We already figured that out. The numerator was a little more challenging, so I solved it and got negative 4. Every x gets a dot. So one from the top, one from the bottom. Now, these dots should be colored in, just like they were over here. So what? What's going to get colored in?
Not negative 3.
Not negative 3. Negative 4 is going to go ahead and get colored in because it's coming out of the top, and the top's no problem. But any dot in the denominator will be open, right? All right, let's pick a number. 2, 1, 201, doesn't matter, 201's fine. Be careful, I'm gonna put, I'll just say 2. I'm gonna put 2 in here. So what do I get? Do this carefully. If I put 2 in there, I get negative 10 minus 20, right? Negative 10 minus 20 over 5. Isn't negative 10 minus 20 negative 30? And when I divide it by 5, I get negative 6. Is negative 6 less than 0? Is negative 6 less than 0? Negatives are less than 0, right? So that means where the 2 is, which is out here, gets shaded. So my answer is negative infinity to negative 4 with a bracket, or negative 3 to infinity with a parentheses. Those of you that wanted to pick 1, that would also have worked. And you would have shaded out here just like we did. Any number out there is gonna work. All right, guys? Okay, let's look at the next one. Now, this is one where the shortcut will not work. How do I know when I look at this problem that my shade, don't shade, shade, don't shade, that my alternating won't work? How do I know that won't work here? Yeah, right there, that's the problem. That's when your shortcut doesn't work. Okay, no big deal. It just means, it's already factored, so I know I've got dots at negative 4 and 1, right? But it just means now that I'm gonna pick a number here, I'm gonna pick a number here, and I'm gonna pick a number here. So I'm gonna have to pick 3 numbers. Instead of just 1, I'm gonna have to pick 3. What about these dots? It looks like they ought to be colored in. And now we start picking. So what's the number out here?
2.
2. If I put 2 in, what's 2 plus 4? Squared, 36. Put 2 in, you get 1. 36 times 1. Is that less than 0?
No.
No, so I'm not going to shade there. All right, now pick a number in here. -1. -1 plus 4 is 3, but it's squared, so it's 9. -1 minus 1 is -2. When I multiply 9 times -2, am I less than 0? Yep. All right, pick a number out here. -5. -5 plus 4 is -1, but I'm squaring it, so it's 1. -5 minus 1 is -6. Is 1 times -6 less than 0?
Yes.
So that gets shaded. Take a look at that for a second. I think the answer is this. Because isn't everything to the left of 1 shaded in? So this is the answer. Now be careful. If these dots had been open dots, then I couldn't do that, could I? If they had been open, then I would have to do this piece, union this piece. But because they were all colored in, it's all shaded, and that's my answer.
Did you have to check all of them because of the square?
Yeah.
But otherwise you can assume it's everything.
Yeah. Yeah, you gotta check all of them because of the square. Oh, Jesus, one more of these, okay, one more inequality, and this one looks big. Okay. When I recopy it, is it okay with you if I bring my 15 over? Because I need to have it equal to 0, don't I? So I'm gonna go ahead and bring that 15 over. Okay? Sometimes we have problems like this that have factors by grouping.
It's just synthetic division.
Yeah, this does not look like it's gonna factor by grouping when you've got 23s and 9s, right? That just doesn't seem good. So, Josh, you're gonna use synthetic division. What are the numbers you're gonna think about trying?
15, 5, or like, 5.
1, 3, 5, 6.
Yeah, factors of 15, that is not hard, Josh. Factors of 15 are right there, right? So the reason I wanted to mention that was, you guys love to pick 2, and a lot of times 2 works. 2 is not going to work in this problem. 3 might, we can try 3. Wait a second. Another little thing to consider. See how all these numbers are positive? Is there any way I'm gonna get a 0 with all positives?
No, you gotta
Let's
put it
try
back
-3.
yeah.
Do you understand what I'm saying? If I do a positive, isn't everything gonna stay positive?
Bigger, yeah.
And it's never gonna be 0, so I'm gonna go ahead and try -3.
And then if they were all negative, you should do a positive number.
I guess, I don't know. I'm not gonna realize oh, we got one, we got one, we got one.
You guess.
No, if they were all negative, I'd need a negative number to change signs. Cause I need some positives, yeah. Okay. All right, now what? So we guessed a good one, good, okay. What do we do now?
Turn the bottom into a.
So x squared plus 6x plus 5?
Yep.
Which is,
Oh, Jared's
5 and 1.
5 and 1. You guys need to remember when you FOIL, this times this has to be that. You don't have any choices. 5 and 1 are the only things that times to get to the time, the only whole numbers.
Do we do a number line for this one?
We do. How do I know? Because it's that, and every time it's that, I do a number line. Right? Now, be careful. How many dots are going on the number line? 3.
Oh, because the
How do I know that 3 dots are going on the number line?
because the minus 3.
I have 3 x's in my problem, x cubed. So there need to be 3 factors. What is that third factor? X plus 3, very, very good. This number right here is a dot. So the dot's gonna be at -5, -3, and -1.
And they're all colored in, right?
What?
Are they all colored in?
Yep, they are. They're all colored in. Now, none of them are squared. So I can just do one. I can pick one number. What would be a good number to pick? You don't have to pick negatives. One? One would be a good number to pick. 1. What happens if we put 1 in here? We get 4 times 6 times 2. Now you don't even need to work that out. You certainly can. It doesn't matter. You're just checking to see, is it less than 0? No, isn't that going to be positive? Positives are not less than 0. So that means this area didn't work. So if that one didn't work, then this one will, won't, will. So negative infinity to -5 in union with -3 to -1. Now that isn't a hard problem, but there's a lot to it. There's a lot to it. Biggest mistake I'll see, I bet, on this problem is, I'll see 2 dots on the number line. I'll see these 2 dots on the number line. Do not forget about the one you guessed.
So we picked -3, so how come when we put it in the parentheses, it's +3 instead?
For the exact same reason that when I plot this on the number line, where do I plot it?
-5. Okay.
Same exact reason. When you put things in and out of the parentheses, they change sign. Right? Okay, E is not an inequality. E is an equation. Full of fractions. What am I allowed to do with equations that are full of fractions?
Find a common denominator.
Find a common denominator and ditch them, right? So what's gonna be my common denominator with a 5, an x, and a 10? There are many, there are many. 10x would be 1. If you said 50x, that would be fine. There are lots of common denominators. Just make your denominators match something. So if we go with 10x, then this one will have to be multiplied by 2x. This one by 10, and this one by x. If you're going with a different common denominator, then you're gonna be multiplying by different things, but in the end, it's all gonna come out. We're gonna get the same answer. So would everybody agree that now my denominators match? So this is multiply, so 18x plus 30 equals 7x. So 30 is negative 11x, subtracting 18. And it looks like x is negative 30/11ths. Remember, I'm making these problems up, so we're not concerned when we get crazy answers. Anybody have a question about that? Any question, issue? Good? All right. Now we have another equation, just like this one, only bigger. So we're gonna strive to get a common denominator and then lose them. So what are we gonna do first?
You gotta factor
We gotta factor that guy right there. And chances are, what are the factors going to be?
The other two, no.
Chances are, it's gonna be 2x minus 3 and x plus 1.
Yes.
Let's FOIL that, just to make sure. So 2x squared plus 2x minus 3x minus 3. Does all of that add up to what I started with? Guys,
Yeah.
what's 2
Yeah, yeah,
minus
yeah,
3?
Yes, yes.
Negative 1,
One.
right? So it does, it matches. So those are my factors. And that is my common denominator.
Yes.
So this one is going to need
X plus 1.
x plus 1. This one is going to need 2x minus 3,
Got it.
and that one's good. Alright, so here we go. Lose the denominator, so we have 4x plus 1
2x
plus
squared,
x,
right?
2x minus 3
Okay, now.
equals negative 8x.
Yes.
Those are just my numerators. So now I'll start cleaning it up. So 4x plus 4 plus, we distribute, 2x squared minus 3x
I know sometimes.
so we have 2x squared plus x plus 4 equals negative 8x. I added these two together. What do I need to do now?
Would you move the x to the negative 8x?
You want to get a 0. So you're gonna combine those, but you're gonna move the 8x over
So you
here.
add 8.
So that's gonna be 2x squared plus 9x plus 4.
Yes.
Anytime you have a squared, you're gonna want to get 0.
What's the equal?
Believe it or not, that factors. Anybody know how it factors?
2x plus 1, 6 plus 1.
Very good, Jared. I don't know what went through Jared's mind, but I'm sure part of what went through his mind was, I've got a 2x squared, therefore I have to have a 2x and a 1x.
Jared's the best.
That's how you get 2x squared.
He actually is. He gets it so fast.
And now I need a 9 in the middle, so what if I put a 4 here and a 1 here? Now that's gonna give me my 4. What happens on my outsides? 8. Insides are 1, And 8 and 1 adds up to 9. If you can't do that, then you're gonna have to use the quadratic formula, and some of you need to practice that, because you're not getting the right answers when you do that. You're gonna have to get your arithmetic under control.
For our answer, do we solve?
Oh yeah, we're not done.
Yeah.
The answers are x equals. So what does x equal?
-4.
-4 or -1/2. Now again, nobody says you have to do that in your head. Set it equal to 0 and solve it. These are the ones that you have to worry about extraneous roots. These are not extraneous. The extraneous answers would be 3/2. X can't be 3/2. And x can't be -1. But this is the kind of problem where you have to keep an eye on that when you do it. We don't have it. These are the answers. We're done. But sometimes we're not. All right. Here we go. 2-word problems, and we're done with this test. Guys, this is such a short test. Here we go. How much 9% solution must be mixed with 3% solution to get 15 gallons of 5% solution? Now, let's take the time to write out our, I don't know, whatever you want to call it, your setup, the structure of your equation. So you can at least get some credit for getting some of the numbers in the right spot, right? Because you know all the percentages. So we have 9%, watch it, that's 0.09. 9%, 0.09. And 0.03 and 0.05. Okay guys, that will trick you if you're not paying attention. What's 0.9?
Like 90%?
90%, yeah, so make sure 9% is 0.09. Okay, how much? Right? And then there's a 15 gallons, where does that go?
105.
Out here. Now, here's what I want you to think about. You have two choices here. This is gonna be 15 plus x, or it's gonna be 15 minus x. Now I want you to think about what's going on. Are you adding these two
Plus, right?
to get this one? Are you adding these two? Are these the two that are getting added to give you this one? Aren't these two getting added to give you that one? So you're not adding 15 and x. It's gotta be 15 minus x. Think about it for a second. If this was 8, 8 plus what gives you 15? Don't you subtract to figure that out? That's what we're doing. These two add up to that one. These two add up to the total. So if you know the total, then you're gonna have to subtract to back up to get this number. All right, 0.09x plus, I'm gonna do some distributive here. And collect my like terms, 0.06x. Subtract I got 5 gallons, is it? Yep. Anybody get that? Okay. And last one. Will and Zane can paint a fence together in 12 hours. Will takes 15. How long does it take Zane? What is our setup for this problem? Now, the one we just did, the setup was amount times percent, amount times percent. What's the setup for this one? 1 over loan plus 1 over loan equals 1 over together. So now you just gotta figure out where the numbers go.
And
So
we'll-
these are the only 3 numbers. It's always 1 over, 1 over, 1 over. So what's the 12? Together. So 1 over 12. What's the 15? That's one of their alone times. What's the other alone time? We don't know. That's what we're trying to figure out. Now I need a common denominator. What?
60.
60. Now, some of you aren't going to think about 60. Some of you are going to think about 15 times 12 and use that, and it's perfectly okay, you guys. You can use whatever common denominator you want. You just have to make sure you can make them both match. Like, if somebody says 30, 30 won't work because 12 times nothing is 30. Well, not a whole number, right? But 60 will work because 15 times 4 is 60. Now I need to make that 4x because I need an x. And then 60, and then 5x. But again, there is nothing wrong with saying, okay, I'm gonna multiply this one by 12x, this one by 180, I think that's 12 times 15, and this one by 15. There is nothing wrong with that. So don't waste a bunch of time and stress trying to figure out, oh, what's the best denominator? There is no best denominator. Just get one. And you can always get it by simply multiplying these numbers together. Okay? So once you get that done, whatever denominator you're using, then you can just set the numerators equal. So we got 4x plus 60 equal to 5x. I got 60 hours. It takes them 60 hours to do it by himself. And that's exactly what you get if you did this format. The answer is the same.
And will the equation always be addition?
Yes, they're working together, right? Okay? All right, well, we're not done. We're not done. Time out. We're not done.
What's our test?
I'm not sure if it's gonna be Friday or Monday. Let's see, I don't see you tomorrow, but I do see you Thursday, but yeah, it's probably gonna have to be, Monday. I think I will stop because that next problem is just too much.
Monday morning.
Too much.